we have the infamous boat problem. The infamous boat problem is assuming there's no friction on the river or the pond or wherever you're in. As you walk from one side of the boat to the other, the boat is going to go to the left as you go to the right. And the reason for that is because the center of mass has to stay constant, no matter what. The center of mass has to stay constant. So when we find the center of mass in the very beginning, that will be where the center of mass has to be at the very end. And interestingly enough, because there's no outside force, the only forces we have is the forces of the boat and the human in between each other. If the human is going to the right, the boat is going to have to go to the left, and the momentum has to stay the momentum that it was in the beginning. So originally, the boat and the human were not moving. So that when we add the momentums as the entire journey happens, the entire momentum will always continue to be zero. The boat would be moving to the left, the human would be moving to the right, but the net would be zero for momentum. All that being said, I'm going to pretend that the human is at the 0 spot, which means that we would have the human as 1/4 the mass of the boat, so 1/4 the mass of the boat, times 0, technically 0L, plus the full mass of the boat, which would be M, times not L, but the mass of the boat, the center of mass of the boat, not the boat and the human, but the center of the mass of the boat and by itself, not the boat and the human, would be L divided by 2, or 1/2 L. That we would need to divide by the total mass of the system, 1/4 M, plus M. And all the M's end up canceling away, which is good, because center of mass is going to be only a length. And if you do that, you end up with 2/5 L. Okay? Which means if this were representing 5 meters, the center of mass of the boat and the human would be at the 2-meter mark. And as the human walks to the right, the center of mass will always, for the boat and the human combined, have to be at the 2-meter mark. Here's where things get tricky, though, because the human did move to the right. And we don't know exactly where he's going to be, other than he's going to be on the right side of the boat. But the right side of the boat won't be at the 5 meters anymore. That's the hard part. So let's just assume that he makes it over here, and let's just assume that he doesn't fall. And if we did the center of mass again, we already learned that the center of mass here was 2 meters to the right. Well, if he's on the far right side, where's the center mass going to be? 2 meters to the left, which in terms of the boat would be at the 3-meter spot, correct? Okay, well, that's not good, because the center of mass needs to be at the 2-meter spot. So I'm going to redraw the boat carefully. It's very difficult drawing. We got boat. We got human. We got the center of mass, which was really at the 3-meter spot. And we need this 3 meters to align with the original 2, which by doing so, you can tell that the boat has to move to the left. Well, how much would it have to move to the left by if we're going from 3 to 2? It would have to move to the left by 1 meter, okay? So the boat has to move by 1 meter. But in this case, we don't really know it's actually 5 meters long, so it would be really 1/5 of the length. You wouldn't really be able to say 1 meter. It'd be 1/5 of the actual length of the boat. It'd be what the boat would move to the left if the person goes to the right. Okay?